Hello everyone, welcome to this last lecture of Industrial Engineering for one-shot series. And today we are going to discuss forecasting. This forecasting is a very important topic as far as GATE is concerned, and it's a very easy topic. It's a very easy topic and very small topic as well. So this forecasting for GATE, we can finish it off in 1 hour. Okay, na? Because there is only a set pattern of questions, and if the fundamentals are clear, you will be able to hit every single problem. So for GATE, things are very easy. You don't have to do anything. At the last, I am going to discuss a separate problem of exponential smoothing and moving average technique. That problem I will discuss only for UPSC because most of the Indian author books, they don't have that kind of stuff, and this problem appears in UPSC. UPSC means Civil Services, IFS and all that. Now IRMS. So only for that exam I will discuss the last problem. I will tell at the time of discussing that now I am discussing only for UPSC. But GATE syllabus thing I can finish it off in 1 hour. Okay, na? Forecasting is very easy. This is our team. So what I am going to discuss, I am going to discuss the trend line. I am going to discuss the forecasting errors. I am going to discuss moving average technique, and I am going to discuss exponential smoothing. There are 3 types of forecast: long range forecast, medium range forecast, and the short range forecast. Long range forecast means next year, next 5 years, next 20 years. So generally the trend line is used for long range forecast, where we are talking in terms of year, 5-year plan, 10-year plan, 20-year plan. Moving average technique is used for medium range forecast, next month, next quarter, or maximum next year. So medium range forecast. This exponential smoothing is meant for short range forecast, next hour, next day, next week, or maximum next month. In the share market, how the share prices will go. One of my students, he is a very good faculty, and he, along with the teaching, he deals with the share market. So anyway, he must be using exponential smoothing. Just while teaching, basically, I got that idea. I will ask him whether you are using exponential smoothing technique. So these things are used in share market. So before I start, these are my credentials. I am gold medalist from AMU in BTech because I was university topper. 93-97 batch. I am MTech and PhD from IIT Delhi. Between MTech and PhD, I worked for engineering services for 1.5 years. Presently, I am a researcher along with teaching all of you. And as per Scopus data, I am top 5% researcher in the world for year 2020. So now, let us discuss the trend line first. Trend line. By the way, trend line is meant for long range forecast. So there is some data. This Y can be demand, and this is the period. First year, second year, third year. So we have a lot of data. We have lot of data like this. We have lot of data, scattered data on XY, and this data we are fitting with a line. We are fitting with a line. This line is called trend line. Actually, still, quite possible I have COVID actually 15 days back, because this bronchitis, it is not going. My brother, who is doctor, he says that you might have COVID because COVID is spreading in China. It's quite possible in India it might be, so be careful. Almost 15 days are over, still coughing is there, and that's the reason sometime I go side. So be careful, all of you, please be careful. Wear mask whenever you go outside, and if possible take booster dose, because when I'm recording this lecture, there is a serious problem in China and Japan for COVID, and India it may come. Please be a responsible citizen of India. So whatever data is being available, let us fit a line. In exam including gate, do not mug up any formula. Do not mug up any formula. So let us say the trend line equation is y is equals to mx plus c. M and c are constant. So let us calculate the value of m and c, because we have n period data. Because we have n period data available. So take summation. See the way I am doing, don't mug up any formula. I am not basically advocating mugging up anything, okay na? Take summation. Summation y is equals to m summation x plus c summation 1, because c is a constant. So comes out to be summation y is equals to m summation x plus nc, because we have n period data, n from 1 to n, so it will be n. Now do one thing, this equation multiply by x. So I will get xy is equals to mx square plus cx. Do the summation here also. Summation here also. Summation xy is equals to m summation x square plus c summation x. Now do one thing. Equation 1 should be multiplied by summation x. Equation 2 should be multiplied by n. Okay, so let us do that. See, these are the simple derivations. Okay, summation x summation y is equals to m summation x square plus nc summation x. This I have multiplied by summation x, and this you multiplied by n. N summation xy is equals to mn summation x square plus nc summation x. Subtract. This will cancel out. So you will get summation x summation y minus n summation xy is equals to m common out summation x square minus n summation x square. So value of m is nothing but, I can get the value of m. So we can reverse it also, because of every book gives that formula. N summation xy minus summation x summation y divided by n summation x square minus correct. So this is the value of m. I have just proven. Do not believe in mugging. See, I have proven easily. How to calculate the value of c? C is equals to 1 by n summation y minus m summation x. You will get the value of m from here, put it here. You will get the value of c. So, if it is a trend line, these are the values of m and c. But one question comes to our mind. One question comes to our mind. That the given data I am fitting in the form of a trend line. Data I am fitting in the form of a trend line. How much accurate it is? How much accurate it is? Whether data actually falling on the line or the data is not falling on the line. If the given data is not falling on the line, our forecast will be wrong. If the data is not falling on the line, our forecast will be wrong. So how to know that most of the data points are falling on the line? There is a factor called coefficient of correlation. Coefficient of correlation. Coefficient of correlation. This coefficient of correlation R is nothing but n summation xy minus summation x summation y divided by n summation x square minus summation whole x का whole square n summation y square minus summation y whole square. This is called coefficient of correlation. And the value of coefficient of correlation will be between 1 and minus 1. The value of coefficient of correlation will be 1 and minus 1. When the value is 1 or minus 1, when the value is 1 or minus 1, it means 100% points, 100% given data points are falling on the trend line or in its close proximity. Coefficient of correlation 1 means 100% points are falling on the trend line, either on the line or in the close proximity. The value, positive value says the trend line is having upward trend. Upward trend means like this. Upward trend. But when the trend line is having negative value, it means the line will have downward trend. Downward trend. Downward trend means like this. This is the downward, upward trend and the downward trend. In practice, when the coefficient of correlation value is less than 0.5, means 0.4, 0.2, 0.3, correlation value 0 means data do not have any correlations with the trend line. So trend line cannot be used for forecasting. Since the data do not have any correlation, trend line cannot be used for forecasting. But in practice, when the numerical value of coefficient of correlation is less than 0.5, we do not use trend line. When the coefficient of correlation R is less than 0.5, it means less than 50% points are either on the line or in the close proximity, so very less. So generally we will not use the trend line, we will use some other curve. So whatever I have done for the trend line, same thing I will do for the same curve to calculate the unknowns. Suppose value of curve is, let us say, y is equals to ax raised to power b. Same thing I will do for this. So these things you will study in your post-graduation MTech program for our gate only trend line. Other curves you will be studying when you pursue MTech program in any IIT. Okay, na? So let us look at some problems. The good thing about forecasting is variation is not possible. Like lecture number 5, 6, 7, you have to learn a lot. You have to develop funda, and that funda you have to apply in the question. But lecture number 1, 2, 3, 4 and the last one, 8th one, variety is not possible. If you know the funda, almost same type of questions will appear in exam. So that is a good thing about it. Following data refers to the demand for a certain product for 5 consecutive years. Year 2016, 17, 18, 19, 20. So 5-year data, these are the actual demand: 20,000, 25,000, 26,000, 25,000 and 30,000. Calculate the forecast for year 2021 and 2022 and find out the coefficient of correlation R. So there is some typographical mistake. So for year 2021 and 22, calculate the forecast and also calculate the coefficient of correlation. This is the question. So let us solve this question. This is my table. Okay. We use the red one only, I think. Red one is visible. Yeah. So year and the demand is given. So in our formula of trend line, coefficient of correlation required summation xy, summation x, summation y square, summation x square. All these values are required. So from the given data, I have to calculate these values. So now the variable x, to minimize the calculations, sometimes people use 0, -1, -2, 1, 2. You must have done this thing in the 12th class. But here I am saying x is equals to 1, 2, 3, 4, 5. 1 corresponds to 2016. 2 corresponds to 2017. So that, okay na? For 2021, x will be 6. 2022, x will be 7. Okay? So, calculate xy. 1 into this here, 20,000. 2 into 25, 50,000. So multiply and write it here. It is a 78,000. 25 into 4 is 1 lakh. 30,000 into 5, 1,50,000. So that is xy. Okay, na? Now calculate y square. This is y. Calculate y square. So y square will be 20,000 square. So 4 into 10 raised to power 8. Okay, na? 625 into 10 raised to power 6, 25,000 square. 676. 625 and 9. Okay, na? Y square. Y square. So this color, I think it is not visible, so I will be using different color. This color is not visible on the screen. So I will use the black one. 1, 2, 3, 4, 5. And xy will be again 20,000, 50,000, because there is a color contrast, na? So it was not visible. Now this is 78,000, 1 lakh, and 1,50,000. And y square will be 4 into 10 raised to power 8. Yeah, visible. 625, 10 raised to power 6. Just a simple calculation. 676 into 10 raised to power 6. And finally 9 into 10 raised to power 8. So now in the formula, we have given these values. Calculate summation x. 1 plus 2 plus 3 plus 4 plus 5 comes out to be 15. Summation y. Summation y means add all these things. It's 126,000. Summation xy. Summation xy is the addition of these things. It is 398,000. And summation y square. Summation y square is 3226. So summation y square, summation xy, summation y and summation x, everything is given to you now. Now, for a trend line y is equals to mx plus c, this is m and this is c. So if you trend line y is equals to mx plus c, this m we have derived before. Divided by this m we have derived before n summation x square you know summation x, you know summation x square, you know summation xy, you know summation x, you know summation y. X square from here, so 1, 4, 9, 16, 25. So you can calculate summation x square also. You can calculate summation x square also, okay na? So if you put all these values in m, if you put all these values in this formula of m comes out to be 2000. Just putting everything in the formula, whatever we have calculated, put everything in the formula, you will get the value of m. And what is c? What is c? 1 by n. C is this thing we have already proven, 1 by n summation y minus m summation x. And if you put everything here, the value of c will be 19,200. The value of c will be 19,200. So now you have got the trend line. Y is equals to 2000 x plus 19,200. This is your trend line. So this is 1, 2, 3, 4, 5, 6 will be 2021, 7 will be 2022. So these for calculating these forecasts, put the value of x 6 2021 and 2022 put x equals to 7. So for year 2021, x equals to 6. So forecast for year 2021 will be 2000 into x plus 19,200, and that comes out to be 31,200. 31,200 is the forecast for year 2021. And for year 2022, x will be 7. So forecast for year 2022 is nothing but 2000 into 7 plus 19,200 comes out to be 33,200. This is the forecast for year 2022. Forecast for year 2022. Now the question is asking about calculate the coefficient of correlation. Coefficient of correlation R n is equals to 6. Summation x y you know. Summation x, summation y, summation x square, summation x, summation y square. If you put all these values, coefficient of correlation is 0.88. Because it's a recorded one, if it is alive, I could have waited for you to calculate. But it's a recorded one, you will be accessing through YouTube. I'm recording presently. So, coefficient of correlation is directly I'm giving the answer 0.88. You know what is the meaning? If you follow this trend line for this particular demand, 88% points are either falling on the line or in the close proximity. Are either falling on the line or in the close proximity. Okay? Now, there are something called forecasting errors. Forecasting errors. Forecasting errors are also very easy. There are 4 different types of forecasting errors. First one is MAD. MAD means mean absolute deviation. MAD means mean absolute deviation. MAD, mean absolute deviation. So this MAD is nothing but mod yi minus fi, take summation from 1 to n period data. Yi man, y is nothing but y means demand, actual. F means forecast. Forecast predicted by your model. Forecast predicted by your model. So I will calculate all these errors in the previous problem. So this will be F1, F2, F3, F4, F5. Forecast for first. So use the trend line. If you put n is equals to 1, x is equals to 1, you will get this forecast. Because only black color will be showing here. So I will write all these values. 21,200. See how these values came. This is my trend line. If I put x is equals to 1, F1 will come. X is equals to 2, F2 will come. That way. Okay, na? 23,200, 25,200, 27,200, and 29,200. By using the trend line, you can calculate all these values. This is yi and this is fi. So yi 20,000, yi mod means we have to take the positive value. Even if it comes out to be negative, still we have to take the positive value. So 20,000 minus 21,200 means 1,200. Mod means we have to take the positive value, even if it comes out to be negative. So y2 minus f2, y3 minus f3, y4 minus f4, y5 minus f5, n is equals to 5. Put everything. You will get MAD, and MAD is approximately 1360. If you calculate MAD, it will be around 1360. So you know what exactly MAD tells you? In any forecasting technique, what exactly MAD tells you about? MAD tells you whatever forecast you are predicting, this will be the approximate variation in between. This will be the approximate variation between the forecast and the actual demand. This is the expected variation between the forecast and the actual demand. That's what MAD tells you. That's what MAD tells you. Now, MSE, mean sum of square errors. Mean sum of square errors. So MSE is nothing but summation m is equals to 1 to n yi minus fi square divided by n. We square it. So if you calculate MSE for this, it is around this much. What exactly MSE gives you information? It is same as that of MAD, but it magnifies the variations. It magnifies the variation so that it is clearly visible. Oh, there is something out of order. It magnifies the variation. That's it. There is no other additional information provided by MSE. Third one is the average error. Or it is also called bias. It is nothing but average error. So average error is summation I is equals to 1 to n yi minus fi. There is no mod divided by n. There is no mod here. If it is negative, keep negative. If it is positive, keep positive. So average error for this particular problem will come out to be negative, come out to be 0. Now it's a very interesting. What exactly bias or average error tells you? What exactly bias or average error tells you? It tells you, according to your forecast, you will be doing the production. Hear very carefully. It's very, very interesting. Here for 2 minutes, you hear very, very carefully. According to your forecast, you are going to produce the component. If something is left out, it goes to stores. And if there is a shortage, we will wait for next lot. So by average error, we can know that over a period of time, if I follow this forecasting technique, on an average, how much inventory will be built up in my stores, or how much shortage will be building? How much shortage will be building, or how much inventory level will be there in my stores, so that I can take care of. Maybe if there is too much inventory built up in the store, maybe I can think of pausing the production after some time. So this information who gives? Average error or bias gives you. This information is given by average error or bias. But here, the bias is 0. You know what is the meaning? As the time passes, sometime inventory will build up, sometime shortage. This inventory will take care of the shortage. So over a long period of time, neither there is an inventory build up, nor there is a shortage. We want such system. Neither inventory should build up, nor shortage should appear. So who tells that? Bias will tell you. So bias is a very, very important, forecasting error. Very, very important forecasting error, bias. And the last one is a tracking signal. Tracking signal. Last one is a tracking signal. Tracking signal is summation I is equals to 1 to n yi minus fi divided by mad. So what tracking signal tells you? If it is a positive, it gives you a signal that in future inventory is going to build up. And if the tracking signal is negative, it tells you in future shortages are going to appear. So you can take some corrective action. That's what tracking signal tells you. And the tracking signal for this particular problem, because bias is 0, so tracking signal is also 0. Tracking signal will tell you in future how much inventory buildup is coming, or shortage is coming up. So these 4 are important forecasting errors. Please remember, for presently I am teaching for GATE. I told you for UPSC I will tell you something in the last. This is all for GATE, whatever we are discussing till now. Sometime in GATE, very, very beautiful problem appears. So you have to be a bit careful. Okay, na? So now there is another additional problem. For the same data for year 2021, with 95% confidence, with 95% confidence, what will be demand? This is an additional question linked to this particular problem. See, for 2021 we have calculated the demand. For 2021 we have calculated the demand, that is 31,200. For year 2021, demand is 31,200. Demand is 31,200. But question is asking, with 95% confidence, you tell me in what range I will get demand. In industrial engineering, this confidence appears at many places. In industrial engineering, this confidence appears at many places. Percentage confidence 68%, 95%, 99.73%. So whenever this confidence is given to you, immediately you should come to the normal distribution. Immediately you should come to the normal distribution. What is exactly this confidence? What is exactly this confidence? For a normal distribution, confidence is percentage area on normal distribution, percentage area of normal distribution equally distributed on both the side. Equally distributed on both the side. So if you go 3 sigma this side and 3 sigma this side, this area is 99.73%. So I will say it's a 99.73% confidence. So X bar plus minus 3 sigma. It's a 99.73% confidence that my demand will be this. If the area two sigma on this side, 2 sigma on this side, this is the 60% area. For 68% confidence, X bar plus minus 2 sigma. X bar plus minus 2 sigma. And all normal distribution only. X bar, sigma on this side, sigma on this side. This area is a 68%. So with a 68% confidence, technically speaking 67 point something, but doesn't matter 1%, 67 point something or 68. So this that much confidence means X bar plus minus sigma, X bar plus minus sigma. Confidence means normal distribution area equally distributed on both the side. Equally distributed on both the side. But our question tells you with a 95% confidence, X bar is this. So my answer is X bar plus minus 2 sigma. X bar is 31,200. Now the question comes out to be how to calculate standard deviation. How to calculate standard deviation of this normal distribution. How to calculate the standard deviation of this normal distribution? So it is I is equals to 1 to n yi minus fi square divided by n minus 2. Y is a demand, fi is a forecast. This is yi, this is fi. So 20,000 minus 20,000 for 200. So we have calculated in the forecasting errors also, na? N is equals to 5. So this factor you have calculated in forecasting errors divided by n minus 2, n is equals to 5. This will give you standard deviation, and it is 1897.3. 1897.3. So with 95% confidence, my forecast is 31,200 plus minus 1897. So minimum and maximum value can be calculated as 27,405, 27,405 to 34,994. In this range, I will have forecast. In this range, I will have forecast with 95% confidence level. With 95% confidence level, I will have forecast, I will have actual demand in this range. If it is a 99.73% confidence, I will do plus minus 3 sigma. If it is a 68% confidence, I will do x bar plus minus sigma. So these are easy questions, but you should know the respective formulas. Okay, na? So till now, whatever I have discussed, it is everything related to, trend line. And the trend line is meant for long range forecast. Trend line is meant for long range forecast. Okay? Because it's a one-shot concept series, so I will not do the questions, repeat question. I mean, same type of questions I will not be repeating. Some PYQs are there. In the regular class, we will do slow. And all the different, not only varieties, but same type of questions to make you practice, that we will do in our regular classes. Okay? Now let us go to the next, to the moving average. Let us go to the moving average technique again. Moving average. These moving average techniques are very, very easy. Very, very easy. And the moving average techniques are used for medium range forecast. So let us take one question and try to understand it. The following data means year 1 to first year, this is the demand. Demand for 12 years is given to you. Certain product for 12 consecutive years. 50% weight for recent data, 30 to 20% weights are given to the previous data. Okay, na? These are data. Okay, na? First question, calculate the forecast for 13 year using 3-point moving average. 3-point moving average in a simple moving average method. You know, in simple moving average, 3-point moving average, what we have to do here, very carefully, these are very, very easy child problems. 3-point moving average means take last 3 years data and calculate average. Meaning 31.9 plus, no. 34.3 plus 35.2 plus 36 divided by 3. That is answer. If it is a 5-point moving average, take the average of last 5-year data. If it is a 5-point moving average, calculate the average of this. 1, 2, 3, 4, 5. Average of these things, that is the answer. 4-point means average of 4. That's it. Simple moving average. If it is a weighted moving average, when we can apply weighted moving average? When the weights are given to you. When I can apply the weighted moving average? When the weights are given to you. Weights are given 50% recent, then 30%, and then 20%. So answer B will be, most recent data is 36. So 36 into 0.5. Next data will be 30%. Multiplied by 35.2 plus 0.2 into 34.3. Because 0.5 plus 0.3 plus 0.2 is 1, so divide by 1 doesn't make any sense. So these are the answers. 35.167. And second one is 35.42. So the moving average questions are very easy. Moving average questions are very easy. Total we have 3 faculties of industrial, and everyone is champion. And everyone is a champion. So they will teach you all these things in detail. Now, for regular class paid courses, because this is basically one short series where all the concepts are discussed in crisp manner. Now, here also we can calculate MAD. So I will give you the technique how to calculate MAD, but I will not go to the details of that. So here, and the demand. So you have given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now here, some demand is given to you. Demand is given to you. So if it is a 3-point moving average, if it is a 3-point moving average, then calculate the forecast. Average of these 3, write it here. Okay? Average of these 3 will come exactly here. Average of these 3 will come here. So you will get forecasted data up to here. So this is YI, this is FI. Total was 12, but there is no FI data for first 3. So n will be 9. In the MAT formula, yi minus fi mod divided by n, this n will be equal to 9. 12 years data is given, but first 3 years we don't have any forecasted data. So n will be 9 here. And yi is known, fi is known, calculate MAT. So moving average techniques are very, very easy. Moving average techniques are very, very easy. Okay? Moving average techniques are very, very easy. So trend line and the moving average. Now next is the exponential smoothing. Next technique is exponential smoothing. Exponential smoothing. In exponential smoothing, what we do, previously we have forecasted something. So previous period forecast and demand, whatever is the difference, I will tinker little bit. I will tinker little bit. So exponential smoothing. Exponential smoothing I will tinker little bit previous forecast and demand. Suppose you want to calculate the forecast for nth period, it will be fn minus 1 plus yn minus 1 minus fn minus 1. What is the difference? I will multiply it with one factor. Fn minus 1 is the previous period forecast. Previous period actual demand. Previous period actual demand. So last period I have forecasted something, and the difference I will tinker little bit. Alpha is called smoothing constant. Smoothing smoothing constant. Alpha is called smoothing constant. Okay, so now let us dismantle little bit. Fn, can I say alpha yn minus 1 plus 1 minus alpha fn minus 1? Yn minus 1 is the actual demand. Same formula, this is called first order smoothing equation. This is called first order smoothing equation. So same equation can I write for the last period? Alpha yn minus 2 plus 1 minus alpha fn minus 2 Put this value of n minus fn minus 1 here. So you will get fn is nothing but alpha yn minus 1. Put the value of fn minus 1 here, plus alpha 1 minus alpha yn minus 2 plus 1 minus alpha square fn minus 2. Correct, na? This is called second order smoothing equation. Second order smoothing equation. Second order smoothing equation. Okay. So, and the same thing, it keeps on expanding. Fn is equals to alpha n minus 1 plus alpha 1 minus alpha yn minus 2 raised to power. Suppose if you want to see nth order equation, n minus 1 f1. The value of alpha will be less than 1. Generally, the alpha lies between 0.2 to 0.8. Generally, the value of alpha lies between 0.2 to 0.8. Actual demand of last period. Actual demand of last to last period. Value of alpha will always be less than 1, and generally it is between 0.2 to 0.8. There is a very important observation I can see from this formula. From this formula, I can see a very important observation that whatever is the smoothing constant, this is the smoothing constant. So whatever is the smoothing constant, as the data gets older, its weightage keeps on decreasing. Let us say alpha is equals to 0.8. I want to show you what I said. So it is a 0.8 yn minus 1. This will be 0.8 into 1 minus 0.8 is 0.2. 0.16. So last period weightage is 0.8, 80%. Last to last period weightage is only 16%. There is one more observation I will tell you. If the smoothing constant value is high, we are giving more weightage to the recent data. If the smoothing constant value is high, we are giving more weightage to recent data. More weightage to recent data. And if the smoothing constant value is low, we are giving more weightage to the older data. Okay, right? Remember this thing, because very beautiful theoretical question can be formed on that. Whatever I have just said. If our smoothing constant value is high, we are giving more weightage to the recent data. And if my smoothing constant value is low, more weightage is given to the previous data. Correct? Now look at the problem here. The following series of 20 observations of company sales of a company are given followed. 10 observation, no? Because no, we have some, I got it typed. 10 observations. So 390, 390, 320, 370, 340, 330, 340, 390, 310. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is your demand. Given initial forecast is 350 lakhs. Is a 350 lakhs. F1 is given as 350 lakhs. F1 is given as 350 lakhs. Compute the difference between smoothing coefficients alpha 0.5 and alpha 0.1. Means you have to find out F11. Eleventh year forecast by smoothing constant. So we will use the same formula. Do not get into any complications. This is the formula. Fn is equals to y alpha yn minus 1 plus 1 minus alpha yn minus 2. y1 f1 is given. You can calculate f2. Correct? Now these two are given. You can calculate this. It's a long problem so that you got sufficient practice. In GATE, very small problems will come. In GATE, very small problems will come directly based on formula. You can calculate this. These two are given, you can calculate this. These two are given, you can calculate this. So you will get F11. You can do one thing. Those who are seeing this video, if you are having pen and paper with you, you can pause the video for 5 minutes, calculate all the values. Answer will be 343.75. If you follow alpha 0.5. If you follow alpha 0.5, answer will be 343.75. And if you take alpha as 0.1, if you take alpha as 0.1, answer will be 349.9. So you will get a sufficient practice. There is no other rocket science in exponential smoothing. Whatever theory I have taught you, that's it. There is no other rocket science in exponential smoothing. I hope everyone is okay. I hope everyone is okay. Forecasting is easy. Till now, I have discussed for GATE. Exponential smoothing is easy. Moving average is super easy. Trend line is easy. Correct, na? So till this portion of lecture, my target was only GATE. But many students, they communicated me through personal telegram chat or email that appreciating the lecture. First of all, I would like to thank you. Based on their questions, they requested me, sir, include something related to civil services, because a certain type of questions appears in UPSC related to forecasting. So I'm discussing the last question only for those people. Those who are appearing in GATE, better to have knowledge. But this last question, please do not take it seriously for GATE 2023. If you are IRMS, IES, IFS, IES, yeah, definitely you should see what I'm doing. Because this type of thing, Indian author books, they do not discuss. Indian author books, they do not discuss this type of thing. Okay? So now, it will take us around 15 minutes to solve this problem. Because most of the book, it is not available, and UPSC, this problem appears. So see very carefully. Using the 4-point moving average, calculate the quarterly forecast for next year in the following data. This table is given in the solution. Okay, na? So third year, question is, for fourth year, what is the forecast for Q1, Q2, Q3, Q4? Question is asking about that. Quarterly forecast for fourth year, Q1, Q2, Q3, Q4 by using 4-point moving average. This is the question. It can be 3-point moving average, it can be 2-point moving average, but I am taking the example of 4-point moving average. Okay? So this I am going to solve. This I am going to solve. So here, quarters and demand. First year, Q1, Q2, Q3, Q4. Second year, Q1, Q2, Q3, Q4. Third year, Q1, Q2, Q3, Q4. And the demand is given to you because question is there in my book. So I'm just following my book. Once again, this book will be available in open market in February end. 200, 350, 370, 250, 270, 410, 320, 190, 300, 400, 310, and 205. Okay? Once again, this particular problem, because forecasting, I want to complete the forecasting syllabus. This particular problem I am discussing only for UPSC people. GATE, such a lengthy problem cannot appear. So UPSC means civil services, IFS, IRMS, engineering services. This problem I am discussing only for those students. Because especially a few students requested me to, especially this particular problem, such type of problems, how to handle. Okay, na? I have to calculate the forecast for fourth year of individual quarters. Okay. Now, next you calculate, next column is 4-point moving average. 4-point moving average value we have to calculate. See very carefully to your screen. Very carefully you should look at the screen. 4-point moving average I am calculating. Look at the board. 4 right exactly in the middle. If you are not able to draw correctly, there will be major problem. Average of these four, write exactly in the middle. Average of these four, write exactly in the middle. Average of these four, write exactly in the middle. Okay, giving you 1 minute free time. Can you work out? I will directly write it because some workout time should be given to you, although of course it's a one-shot series. So if you do that, these moving average values will be, so you have to write exactly in the middle, otherwise it is going to be a mash. Otherwise it is going to be a mash. 292.5, 310, write exactly in the middle. 325, 312, 297.5, 305, 302.5, 300, 303.75. Now next is centered moving average. Centered moving average. Centered moving average is, look at the board. Calculate the average of these two, write exactly in the middle. So this value will be exactly in front of this value. Average of these two, write exactly in the middle. So this value will be exactly in front of this. Okay? So if you do that, there is no centered moving average in front of first two values, and there will not be any centered moving average value for the last two. For remaining, centered average value is 301.25, 317.5, 318.75, 305, 301.25, 301.25, so this is the center moving average. Okay. So if you are focused, calculations are easy, but if you are not focused, your mind will become heated up. Where is going what? Which value is going where? Next column, in the last column is seasonal index. Seasonal index. Sometime in GATE also they asked you what is exactly the seasonal index. Here the seasonal index is nothing but demand divided by the centered moving average. Demand centered moving average is called seasonal index. So my next column is the seasonal index. For first two, there is no seasonal index. Demand means 370 divided by 300, 1.25 seasonal index. 250 divided by 317.5 seasonal index. Means proportion seasonal index comes only when the demand is given quarterly. Seasonal index will come only when the quarterly forecast or demand is given. For a particular quarter, what is the contribution in forecast? That's the seasonal index, okay? So quickly calculate the seasonal index. I'm waiting for 30 seconds so that at least some kind of exercise you can do. Some kind of exercise you can do. So the seasonal indexes are 1.228, 0.784. It's a good practice. If you are slow in calculation, pause the video. And when you are done, just continue. 0.8471, 1.34, 1.06, 0.99, and 1.32. Okay, so these are seasonal index. And how I have calculated the seasonal index? Demand divided by the centered moving average. Demand divided by the centered moving average. Now let us prepare a table of seasonal index. There are 4 quarters: quarter 1, quarter 2, quarter 3, quarter 4, and 3 years data we have. So first year, first 2 quarters we don't have seasonal index. Then we have 1.22, 0.78, second year 0.84, 1.34, 1.06, 0.62, .99, 1.32. Then you calculate average seasonal index. Average means this plus this divided by 2, write it here. This plus, there is no seasonal index here and here. This plus this divided by 2, write it here. This plus this divided by 2, write it here. This plus this divided by 2, write it here. So seasonal index for quarter 1, seasonal index for quarter 2, seasonal index for quarter 3. So all these seasonal index values, average seasonal index value you will be getting. It's a 0.92, it's a 1.33, 1.14, So all the average seasonal index values are given on the board. So calculate all average seasonal index value. Seasonal index value, if you see the theory, what it tells you, seasonal index value, what it tells you, proportion of demand for a particular quarter, you can say like this. Okay, seasonal index value I have calculated by this procedure. Now forecast for next year. Now what will be the forecast for next year? Forecast is equal to the seasonal index multiplied by most recent value of centered moving average. Centered moving average. How to calculate forecast of individual quarter? It is the seasonal index multiplied by the most recent value of the centered moving average. Most recent value of the centered moving average. So for fourth year, forecast for quarter 1 will be seasonal index for quarter 1 into most recent value of centered moving average for quarter 1. Forecast for quarter 2 is nothing but seasonal index for quarter 2 into the most recent value of the centered moving average for quarter 2. Forecast for third quarter is nothing but seasonal index for Q3 into most recent value of the centered moving average of quarter 3. Q4 is nothing but IQ4 into the most recent value. Now for quarter 1, let us see what is the most recent value. Quarter 1, most recent value of centered moving average is here. Most recent value we will see from the down. Na? So this value is given in front of Q1. So most recent value of centered moving average for quarter 1 is 301.25. So IQ1 was how much? 0.92. So 0.92 into 301.25. Most recent value of centered moving average for Q2 is this 301.87. And IQ2 was how much? 1.33. 301.87. Now, what is the most recent value for centered moving average for quarter 3? Is here. Most recent value of centered moving average for quarter 3 is 301.25. And what is the IQ3? 1.44. And the most recent value for quarter 4 is here, Q4. 303.75. How much was the IQ4? 0.7. 303.74. So these are the forecast for individual quarter. 277.45. This is for quarter 1. 402.8 is for quarter 2. 344.9 is for quarter 3. 214.5 is quarter 4. Like for example, woolen cloths. In the summer, there is demand for woolen cloth is very low. Only those who are going for foreign countries, they will purchase the woolen cloth. But in December, January, demand is at peak. So seasonal index tells you where the demand will be more. So for this particular product, here the seasonal index is more. So in quarter 3, demand for this product will be more. In quarter 4, because the seasonal index is very low, demand of the product will be very less. So seasonal index gives you that information. So this last problem I have taught you only for UPSC exams, because 1 or 2 times this such type of questions appear, and students they do not know how to handle. So now this is the complete course of forecasting. So in this 8 lectures, I have completed the entire industrial engineering syllabus for GATE. See, many things are not there in the GATE syllabus now, like break-even analysis and all that. That's the reason I have not touched. Before 2015, those things were there, line balancing, break-even analysis. But GATE 2023, this one-shot series we have designed, and I have taken into consideration that the syllabus is also complete, and we are touching some very important points for GATE 2023. Now, I wish you all the best. Crack the exam and get very good rank. And if there is an issue, get in touch with our team Drona. All the best.